since the fact that it's called parallelogram, I'm going to go on a limb and assume that at least something here is probably parallel. I know, it's a heavy sci day. I think you can make it through. Okay. All right. So, if we have said parallelogram, what do you think you know about sides? Now, is this side parallel to that side? No. We say that the opposite sides are parallel. Do you guys remember the whole idea of the arrows that showed from back in chapter 3? That just means we have parallel stuff. Now, speaking back in chapter 3, let's see if you remember this. When you had two parallel lines cut by a transversal, we had all those angle pair relationships. You guys remember all that? Remember how we just marked the diagram and just walked ourselves through? If they shared a tick mark, they were congruent. If they did not, they were what? They were what?
If they weren't congruent, then they were
Supplementary. Very good. Now take a look at a parallelogram. If you think about it, if I draw this as another side here, aren't these inside angles? Now, what happens is, if you go through this one as well, oops, I went the wrong way. What happens is, you get the opposite sides, the opposite angles within parallelograms wind up being congruent. That also means that consecutive angles, angles that are next to each other, are always going to be supplementary. So, let's make a list. We'll go back and forth here. So we have opposite sides, parallel, opposite angles, congruent. I'll mark my. And then we also said consecutive. Are supplementary, which means they add up to 180. So whether you're going top to bottom or left to right, each angle that's next to each other will always add up to equaling 180. Excuse me. And then the other one about sides. The other one about sides, and I think we tried to do our best with this last week. Remember when we were measuring it out, the length and side lengths? We also had opposite side lengths were also congruent. Opposite sides are congruent. We were able to do that rather quickly with everything that we did as far as the compass and the protractor and just measuring stuff out. Okay? That was not crazy. One of the things that we ran out of time in doing was dealing with the diagonals. And when you have diagonals in a parallelogram, sorry about the really bad drawing. But what happens with diagonals, I tried to get time to show you guys how it works. I think the one that I drew out was pretty clean. Was that the diagonals inside a parallelogram, they always bisect each other. Because when we start going through here, remember we have all these different tick marks? So I put 3 and 3, bless you. Is that okay to put like a little V mark, if you will? You'll see that a lot. A lot of times I may put a little circle on that line. It just, as long as they share the same tick mark or whatever marking it is, it just means they're congruent. And then diagonals. Oops. Okay. So basically, with those basic properties, everything is written. With all those basic properties, no matter what, every other successive parallelogram, if you will, all has the same thing. Everything. So each step down, it's like, you guys know what I mean by family tree stuff, because what is it, like, when you start looking at species, was it genome species thingy? Is that what it is? Genus? You're a genius. See what I did there? That's good. So it's like, what's that? Oh, I thought someone had that over there just making fun of me behind me, which surprised me. What you want to think of is that everything starts with the quadrilateral, 4 sides. More specifically, it's a parallelogram. If that's a parallelogram, then it has all these properties. A rectangle is a parallelogram. It has all the properties, including more. A rhombus has all the properties, including more. A square has all the properties, including more, and so on and so on.
Couldn't we go all the way back up to polygon?
Yep.
Could go back up to polygon.
You can go all the way back up to polygons, and polygons were just multi-sided figures. Same idea when you go back to polygons. How many degrees will be on the inside of a quadrilateral? 360. So no matter what, since it's a quadrilateral, it's a parallelogram, the interior angles are always going to have to equal 360. When you go back into the exterior angles, if you know one of the exterior angles in a parallelogram, you'll be able to figure out all the other exterior angles because of the properties. But because, well, first of all, how many degrees are on the outside? 60. So if you knew just one of them, let's say that you knew this one was, I don't know, 42. If that's 42 degrees, what would has to be on the inside of it? It's supplement 138. If that's 138, the next one has to be its supplement, which was 42, which means this one has to be 138, which means this one has to be 42, and so on and so on and so on. Okay? So it does stuff like that. All right? You look like you don't believe me. I just made it up. I just showed an example. Sometimes I make stuff up as I go. It might be 42 degrees, I don't know. Not close. What? Can't that be precise? No, that wasn't even close. It's more like 65. Whatever. I don't know. The complete box is in the back. Oh, which one was it? So, let me show you some examples. Helps if I get the right file open. What I did, instead of having to draw out 15 different examples, I thought it would be easier to have examples that you can put into your notes. So I whole bunch of things.
Wow, you are awesome.
I said sarcasm. I'm sorry. I don't know, I call me crazy, but I sense that you might be sarcastic with that comment. I can imagine why you want to be sarcastic towards me, and I am nothing but nice to you.
I think you're just crazy.
No, I don't.
Well, I can be crazy, but I can still be nice, right?
Okay.
I will. Good morning. How are you today? Good. I want to make sure you're okay. I guess I got hurt. It's a little crooked, but you're almost there.
You want to do it?
Nope.
Are you sure?
Yes.
Positive?
Yes. I'll get over it. Thanks. Some. All right, so this is really, really difficult. I know. I hope that you guys will be able to figure this one out.
I think not.
I think we're going to be okay. So, if you bear with me here. If it's a parallelogram, what's x and y?
The same as the parallel. So they're parallel. So x is going to equal.
Okay,
X is
so
gonna
this isn't
equal
very
1.
difficult. All right. Now, bless you. I know. You'll be okay. So if you have to solve for the variable,
A equals.
What do you have to do?
17.
Math. Thank you. You're welcome.
A equals 17.
Yeah, again, what happens here, guys, it's one-step equation, two-step equation stuff. It's nothing crazy. It's because the properties. If we just go through the properties, knowing all the stuff through, mark all this. Opposite angles here, here, here. Parallels. So on and so on. All right, so, excuse me. I'm going to skip around to something that looks a little bit more difficult. And because I'm lazy, I'm going to do this. It's much easier. Oh no, I am worrying about the interior diagonals within a parallelogram.
Oh, no.
I don't know what to do. Set equal to what? Set the h minus 7 equal to g, or h minus 8 equal to the g plus 7?
Yep, definitely.
I don't think you're right.
No, I know you.
68.
What do I have to set equal to here, guys?
It's going to equal to,
Not the diagonals to each other, but this chunk and this chunk.
Yeah.
I know. Okay. But, which one really gets weird? I don't use on this side. What I want you guys to do here, I want you to flip over to the other side. And I want you to try and do.
Oh God, there's a proof at the bottom.
Once again, did I ever say that we were going to do any proofs second semester?
yes.
No, we don't do any proofs second semester. Okay. Bless you. Now, excuse me. And I apologize that I did not have this scanned for the smart set. So you have to deal with my awesome drawing. So, remember how we've talked before when you have big picture style problems? I always state that I never want you guys to read the questions. What I want you guys to be able to do
Wait, never
is-
read the questions?
Right. Well, the thing is, Whiskey, I'd rather you go to the actual diagram itself and take the time and fill in everything that you know before going to the questions. By doing it that way, it makes your life easier in the long run. Because a lot of times, if you go back and forth between questions and diagrams like that, you wind up taking more time than what you really do need. So when I see this style problem, what I want to do is fill in what I can. For example, notice how we have the outside measurements, which means what can I put at HK? The opposite side, what can I put at HI? 16. So take a few minutes and see how much of the stuff that you're going to be able to figure out going through it. Now, you could also be able to figure out every single angle that's in there as well. It'll take a minute or two, but you should be able to do that. Okay? See what you can come up with. You should be able to get a measurement for every single angle, the whole chunk, all these other side lengths, and everything under. So let's see, there'd be one. Yeah, there's a bunch. So take a couple minutes, see what you can figure out, and we'll check it. All right, so with any luck, you did this. Then you got that far. Okay? Now what I want you guys to see is that we have this angle of 84 degrees here, which means what has to be its supplement here? Thank you, sir. What has to be its supplement there? What's the supplement to 84? Hi! Thank you.
96. I mean, yeah,
96. So this whole angle here is 96. Well, the other way around, but you're on the right track. Okay. So if you subtract out 28 from 96, what do you get that leftover little piece? How much? 68. Now, that also means that this whole angle here has to be what? Oops. That whole angle has to be what? 84. This whole angle has to be 96. But watch what else you can do. Two parallel lines cut by a transversal. If you look at this 28, isn't that the angle here? If you think about it, which means as it comes back up to here, that would be 28, wouldn't it? Right? Well, yeah, you get that, and you get the 68 bounces to the other side. Now, do we have enough information where we could figure out what maybe IHG could be?
What?
Huh? I don't know.
I don't know.
How? What could we do? What could we do to figure out that? What could you do? What's that? Well, if I do the 180, I only have one angle in the triangle, don't I? Well, you have side angle side, okay.
How do you find a missing?
I think I know.
What is it?
To find, you do 80, 180 minus,
Which what?
180 minus 180 minus 84, then you, get, the 96, and you subtract that by the 96.
Well,
Isn't it like 36?
no, we don't know that. But here's what you could. All right. Am I getting a little more overcomplicated than what we need?
Yeah.
Yes, because it's more fun that way. Yes, it
For
is.
you or for us?
You know. Well, remember.
Magical adventure.
So remember, that's what this is. So let's have a little bit of fun with this. Remember, we put the. Never mind. So.
Go there.
If I take apart the one triangle, and do that, everybody okay with that?
Yep.
Now, I know that, excuse me, this is 8, this is 7, this is 16, and this is 28, isn't it?
Right back to that.
What could I do? What's that? Do I have an angle
Yep.
Yes, you do.
and a side opposite?
Yeah.
No, not this.
I could.
I knew that it was.
I could.
I saw this. Oh, gosh. What can it be?
Oh.
So you could and build yourself out of it.
Why would you use G? That's what it's doing.
Oh, I just picked G because it was the next biggest angle. That's all. There's reasons why you pick bigger angles as you go through a lot of these things. In geometry, it's not that big of a deal. In algebra 2, it's a very large deal that you want to always try to get the largest angle as fast as possible because you will eliminate possibilities of bad things happen. So you could do this, which this isn't tough. Use 16 sine 28 over 8, because he couldn't get away from the buffet.
Oh my gosh.
And I'm scared.
Dave, you're pressing the button. What'd you get for G?
Okay,
What's that?
Something wrong.
All right.
it's 0.94, 0.938.
Is there a different way?
No.
Oh, that's so cute.
That was his birthday party.
Oh yeah, you want to put the 8 inside.
Yeah, why would you just divide the 8 sine 2?
What's that?
Why would you divide the 8 sine?
How?
Well, because you didn't cross multiply.
Yeah, I did. I had to move this over. Oh, because if I move this over, then I'd have to divide it back anyway. Because at this point, I just have to do the inverse.
I see.
So technically what you can do, what's 16 divided by 8? 2. You type in your calculator 2 sine 28 and hit enter. Inverse sine of your answer and you get 69.87 for here. What? And I'm getting 82. Oh boy, this. All right, so this was a bad example to show you guys why I law of sines here, because this is the ambiguous case of the law of sines. So anyway, if I ever decide to be so torturous towards you,
Yes, please.
of course, the one time I want to do an example of something where you can use law of sines, it throws the ambiguous case at you.
I'm done. No thanks.
So technically, the way you're supposed to find this one is to use law of cosines. But anyway, you can do these things. Everything that we've done in the past is still fair game. Remember, I never taught you guys how to add or subtract, multiply, or divide, but yet I expect that you guys know how to do that. I never taught. I wasn't your algebra teacher. So I still expect you guys know how to solve 1 and 2 step equations. Same but basic principles. Okay. Let's try another one. Here's another very common thing that you will see with parallelograms. Words. Now, one of the things I want to remind you guys of is when they say it's parallelogram, they use that symbol for parallelogram. When they say that it is with those letters E, F, G, H, when you go to draw that, just draw like your standard looking parallelogram. Doesn't have to be anything fancy. Pick a letter or pick a spot and just go in order. That's all you're doing. So when they give, it's just a very similar way that we did that with triangles. If it said triangle ABC, you pick an angle and you work your way around. Same deal with parallelograms. It doesn't necessarily say which one is which. But here it says that angle G is 25 degrees less than angle H. Sketch it and find all the measures of each interior angle. Excuse me. So what we need to do is figure out what does that mean. It says angle G is, that's what is stands for, equals. Yeah, you're setting it up to be, you're turning it into an equation. So what I want you to think about, and you'll see this style pretty regularly. E, F, G, H. And it said angle G is 25 degrees less than angle H. So do you put 25 minus H or is it H minus 25? Yeah. now you have to figure out, what do you do with that? So what I want you to think of here is, what can you say about the relationship between angles G and H because there are parallelograms? Very good, they're supplementary. They're supplementary. So what does H plus G have to equal? 180. So what happens here is that you will see from time to time stuff where you get like a little bit of a word problem, but it's asking you to create a system of equations. Now, you guys all have done systems of equations before. Substitution was the very first method of which you guys learned about solving systems of equations. Here it says that angle G is H minus 25. H plus G is 180. So which means everywhere I see a G in my second equation, what am I going to replace it with? Exactly. So here's what I do. H plus H minus 25 is 180. Okay.
All with their crutches in their hands.
And then it's just a matter of dividing out. When you divide that out, what do you get? There you go. 102.5. Now, if that's H, I subtract 25 from that to get G. What do you get?
77.5.
And there's your answers. Is it okay that you get a decimal from time to time? Absolutely. What I need you guys to realize is that decimals show up. Yes, sir?
Can you just do 180 minus 25, then you divide by 2, you still get 77.
That's a shortcut way of doing it, yeah. I'm just showing how you can always set it up to make sure, by using the proper way. Don't worry about it. Set it up in systems. You will usually, you trust me, okay? There's a lot of times it's not a quick, easy. It's not always the same thing. All right? Let's try another one. Yeah, you'll get over it.
It's giving me anxiety.
The answer is yes.
Well, the sound that made was fire.
All right. Take a second. See if you can figure this one out. Like I said. Wow.
Terrible.
I don't know, I haven't done it yet. There, from time to time, then you'll start getting like 2 times the other minus 15. They'll mix it up on you. You're right, a lot of times it is pretty quick, but, and I like to show the long way because you can replicate it, because when it gets tougher, it's easier to know how to do it the long way. W is 50 more than X. Is it okay with you guys if I take the angle symbols off when I write these out?
Yes.
In the diagram, since it's a parallelogram, what do you know that W and X have to add up to equal?
180.
Good. Which means everywhere I see a W, I'm going to replace it with this. There we go. Yes, I know this is the long way of doing things, but it's okay. Because eventually, if it does get, well, when it does get a little bit more complicated, it'll be easier to see how it works. What's that? So you get 65 for X, and then W is 50 more than that, which is $1.15. Okay. Not so, I'm always in a bad spot for you. Not so bad? Let me give you guys some. About what? What happened here was I set this up in order to, what I'm doing here is using what's called a system of equations. It says W is X plus 50. Since they're next to each other in a parallelogram, they have to be supplementary, which means if you take the two of them together, they would equal 180. Bless you. Now I'm using what's called substitution. Everywhere I see a W, I can replace it with, and that's what it is. Okay? And if you think back to when we did proof stuff, we did a lot of that substitution set as well. Okay? It's just a quick algebra thing. All right? Let's see here. Let's do these. So this is 8.2 in the book. So it'll be page, what is it, 518? Numbers. Let's do those. Already today, yeah, you know. If you guys give me a second, I will pull this up in case you don't have your books in front of you, and we can get some of the problems on the board. What's that? Yeah, I'll have it up on the web. I'll have it on the calendar here in a couple minutes. Yeah, give me 1 sec. Here's those, and I'll put them up. If you guys have not written that down yet, and I'll have the first chunk of problems here on the board for you to start. Like I said, you should fly through most of the first page, and we'll get into some more of the crazier algebra stuff tomorrow.
You guys good? You guys should be able to do it all as long as you know math. Okay, that's kind of like your little cheat sheet as you work on your homework. Okay. No, we just kind of working on it. I know, we get excited, like, oh, yay. Oh, you finished the whole worksheet?
Well, except
Kids,
two.
that's your
Yeah, I'll take that.
Let's close this out.
That's like your little cheat sheet.
It's tough here. Let's see if I can do this. Let's see if this helps. Is that better? Don't fall asleep. Yeah, go ahead. Yeah, if you guys want to take a picture and see you have it in front of you, it's fine. No problem. I didn't think I was going to pass a test if I had You don't want to see me in one couple pounds. I'd be very great.
That's okay. I'd rather have you crazy than hyper.
I'm not that hyper.
Yes, you are. We go into the question. Good morning. Yeah, like just that thing. No.
Mr. Murphy, are they offended
It
you?
makes me more upset.
What's that?
Are they offending you?
I'll get over it.
I've seen worse.
Yeah.
You're not even bad. It's not hype. It's just energy. Wait, so you said I'm gonna get credit for that?
Yeah, I'll get in there. That's fine. You just forgot to give it to me. That's no big deal.
Wait, I did the whole page as well.
I know.
Are we on assembly schedule today again?
Yeah, so the first hour is like a minute or two longer.
That was a good one. You gonna watch the game tonight?
Caleb. See you guys. Have a good one.
Bye, Mr. Murphy.
See you later. Would you turn the light on for me, Haley? Thanks.
Mr. Murphy,
Yeah, what's...
do I get extra credit since I did the whole sheet?
No.
Mr. Murphy. Can you not forget your homework assignment?
I got it right.
It's not late, is it?
What?
It's not late, is it?
Oh, you're absent. It's okay, man. Don't worry about it.
Yes, wait.
Don't you wish it would be this easy? Excuse me. Keychain. Oh, pardon me. Pardon me, pardon me.
Here, it's a stuck, alright? It's not like
I think I'm
I just need to know I need to put my finger around here. And this is gonna hit it. They never said you could. And this is why I'm smarter than any psychologist in the world. She gets what?
Oh, I was just
Right triangle trig. Think about it.
in different ways.
Yeah. No, if you think about it.
I think I got a B on it.
I got an A on
Do. Sweet Jane.
Did we get our test next?
I got a bunch of people from 12th hour that ditched school on Friday. You guys did fine. There was a couple of stupid problems here or there, but for the most part, it was pretty.
I know on the non-calculator I forgot to shift on the graphic.
You didn't have to shift anything.
I didn't have to.
No, you just picked points. That's all it was. That's the whole point of graphing with.
I just thought, I was like, do I have to shift? And I was like,
No, that's the whole point of. Hey, get to class on time, bozo.
but somebody told me that I had to shift it. I was like,
No. No, what happened? Remember, when you graph logs, all you have to do is pick points to make the log make it work.
I wasn't here.
Why don't you watch the video, knucklehead?
She taught me that, and I understood.
Hey, so, aren't you excited? We're going to start trig.
No.
You sound really excited.
You know, as dorky as it sounds, coming from, the math teacher, sorry to say, but yeah, trig is one of my favorite things to do. It always has been. It's kind of cool because it's the whole basis of everything you're going to do next year. Like, a lot. Pre-calc, they start trig in around November, and there's just finishing. I know, all right, let me rephrase that. The regular pre-calc class starts trig around November, and they finish it. They're still in it right now. The honors pre-calc class started trig November, and they finished up a couple weeks ago. So it's still a giant chunk of info. And my goal for you guys is to get you ready for all that, so that way you guys just it's a cakewalk. And from what I've heard from the past and other students and whatnot, they've all agreed that it helps. So I know that you guys all did some basic right triangle trig back in geometry. And what we do over the course of this first week is usually all the basic stuff again, albeit a little bit quicker. So if you remember last year in geometry, you guys did all your right triangle trig stuff in probably about 6 weeks. That's about right. Yeah, we do it in about 2 days. Just a quick review. And then we'll do law of sines and law of cosines. Now, I know that Seb did law of sines. Did he do law of cosines also? I know that I did law of sines and law of cosines in regular geometry. I always do. But what will happen this year is that when we get to the law of sines, you wind up with what we call the ambiguous case, which means you have multiple triangles. It's a fun thing. It sounds really, really weird, but there's one quick check thing that we do. You just bounce it into see if something works, and it goes by real quick. So let's do this. Let's see what we remember about right triangle. Oop, forgot that.